So we're looking at exponential smoothing. The meaning of exponential smoothing is simply a forecasting technique that is used to predict the future values based on the previous or past data. So it gives more weight to the recent observations whilst considering the order, though less influential. So exponential smoothing is very useful for short-term forecasts like sales, demand, inventory, especially when data shows no strong trend or seasonal pattern. So the ft plus 1, meaning the forecast for next period, is simply given by the alpha, which is a constant number between 0 and 1. Alpha, actual trend or demand of the current year, plus 1 minus alpha, then forecast for the current period, ft. So this is the formula that we use. So to understand these particular constants that we have, what they mean is as follows. So we need to understand that alpha is simply a smoothing constant that we use. It determines how much weight uh, the recent data carries. So if you have a small alpha of 0.1, it means um, it heavily smoothes the data. It gives more weight to past forecasts and reacts slowly to changes, meaning that 0.9 is for past. If you have 0.3 and higher, it means there's less smoothing. It responds faster to the recent demand. So if you have a demand that has something smaller than 0.1, it means that the demand is stable. But if you have something larger than 0.3, it means that it fluctuates. All right, so we go to our table here where we are asked to predict the given missing data. So we will need to use those formulas to predict the missing figures. So we are given alpha 0.1, 0.2, 0.3, then the data that is there. So how do we find our figures in here? How do we find our figures in here? So we're just from explaining that the formula that we use for the next forecast is simply alpha, actual trend, okay, then plus beta, or 1 minus alpha is just beta, the forecasted trend. Okay, so in this regard, we want to calculate the missing value for F10, the missing value for the forecast for F10. So how do we find the forecast for, this is 10, period 10, F10 here, we're going to find at 0.1 is equal to what? Alpha, then the actual forecast for period 9 plus beta, the forecast for period 9 itself. So here, our alpha here is 0.1. 0.1 in this year, starting from this one to predict the next year. So we want 10. 110, then the beta is simply 1 minus alpha. So if this is 0.1, then the beta should be 0.9. So put 0.9. Okay. Then 0.9 multiplied by the actual forecast, which is 85. The forecast of that particular period. What period is, so just picking these ones here. So what you're actually doing in simple terms is here you put a 0.1 and here you put the remainder, which is 0.9. Okay. So 0.1 times 110 plus 0.9 times 85 to get the answer for here. So what we get when you compute that, we're getting 87.5. We put your 87.5 in here. Okay, 87.5. Then you can prove your answer. If it is correct, you can now continue here. 0.1 times 105 plus 0.9. No, 0.1 times 90 plus 0.9 times 87.5, it should give you this. Then you go again, 0.1 times 109 plus 0.9 times 80, 6.7 to give you that. Then 0.91 times 95 plus 0.9 times 89.1, it should give you this one. Okay. This times that plus this times that should give you that. Are we together? So far, are we together? So let's do the focus for uh alpha using 2. Can somebody tell me how do we find the missing focus in here? Under 0.2. So you put the 0.2 here. And what will be here? What will be here? The remainder, which is 0. What? 8, right? So what is the focus for period 10? So it will be 0.2 against what? 0.2 against what? 110, right? The remainder from 100, 0.2 is what? 0.8. Then 0.8 times what? Actual focus. What is the actual focus in here? It's 85. So when you compute that, what are you getting? You're going to get 22 plus 68, which is 90 exactly. So 90. So where do you put the 90? The 90 will be here. Can somebody try here the focus for this period under 0.3? What computations do we use? Focus for year 10, period week 10. So the 0.3, you bring it here. So what is the remainder? What is the beta for 0.3? 0. What? 7. So you're going to put 0.3 against what? 110.
110
Then 0.7 against what?
plus 85 again.
85 again, correct. So what becomes the final answer? 92 point what? 5. Is that so? So we put here 92.5. All right. All right, people perish because of what? Lack of knowledge for
Knowledge.
simple things. All right. So when you compute properly, you fill in your table appropriately. Okay? And show your workings as has been demanded. So confidently, you will now share your table with the missing values. So this is exponential smoothing. So the row has been filled up now with this value, this value, this value. This one is coming. Please, you can't afford to lose marks. The school makes money by having a number of you fail. I make money from the references. When you pass, I feel nice. So you just don't have to pass for your sake, but for my sake. So are we together? So this is
Sure.
how this row
Yes.
is performing here. These are the values. Okay. Any questions? So now we have what we call the mean absolute um, deviation. It is used to calculate the error that is associated with the forecast. The smaller the error, the more accurate the forecast is. So we have the MAD that is very important to our calculation. So MAD is used to assume the error associated with the forecast. So the most accurate is the least error that you have. It has less errors. So the smaller, the more accurate. So it is given by the actual trend minus a forecasted trend over n. N is the number of observations. Okay. So actual trend over. So when we go to our question here, since we found the answers that we had, here we found it's 7.5. There we found 90 and 92.5. Okay, so we want to calculate our errors associated with these. So who remembers the formula for the error? What's the formula for the error? The MAD? Mean absolute deviation.
Yes, Mr. Chinyama. Hello?
Please mute yourselves. What
Oh, yeah.
is the MAD? We'll be doing the memorizing together. Okay. Very important to go back to our grade 9. Summation of AT minus FT over N. Summation of AT minus FT over what? Over N. So to understand which of these forecasts is more accurate, we calculate the errors associated with this. Okay, so our how do we calculate the error for 0.01 there? The MAD for 0.01. What is our N? Our N is 5, right? We add them up. So we start with 0.01. What is our calculation there? For under 0.01 here. How many are there here? We have 1, 2, 3, 4, 5. Okay. 6. Okay. So we need to calculate the mean absolute deviation, the focus that we have for each of them. So how do we calculate these errors that we have? So you need to recalculate the table here to find the MAD. The actual focus, the forecasted focus, then you have A minus T, then you calculate the error. So the formula for the error is here. Actual trend minus forecasted trend over N. Okay? Actual trend minus forecasted trend over N. So we start from week 8, 9, 10, 11, 12. Okay? So let's calculate the MAD. So this was just for starting. These are not focusing the actual. So we are focusing 1, 2, 3, 4, 5. So what is our actual minus our what? Our forecasted. So here we have 102 minus 35. Okay? What do we get? Okay, so what is actual minus, so this is actual minus forecasted. So you can't use these ones here, 0, 0, 0, 3 also. Actual is what? 102 minus 85, what do we get?
is 17.
Yes. 17 for the first one. The next one?
We are getting 110 minus 86 or what?
Yes, 110 minus 86 point. Yes.
6.7. That's 23.3.
23.3, correct. Mm-hmm. Are you seeing what we are doing, right?
Yeah.
Mm-hmm. Then,
The other one is 90 minus 87 point, is it? 0.5. So
mm-hmm.
that's 2.5.
2.5, yes.
And the other one is 105 minus 89.1. 15.9.
15.9, okay. Mm-hmm.
And the last one, 95 minus 90.7, that should be 4.3.
4.3, okay.
Yes.
So you're seeing the differences here. So the first one here was what? So you need to do for each of these ones here. So the difference, 85, 10, okay. The difference here, the difference here, the difference here. So just multiplying 102 minus 85. What did we get here? We got
That
what?
was
17.
1017.
17, 23.3, and 2.5. 17, 23.3, and 2. Okay, so here we have what? 17. And here we have what? 23.3.
0.3.
Here we have what?
2.5.
2.5, right?
Yes.
And 15.9. 15.9. And finally what?
4.3.
4.3. Okay, are we all understanding? This question is coming, like it or not. So please, I don't want to lose any of you. Are we getting what is happening there? We're just subtracting this minus that, we get that. This minus that, we get that. Then we total this part here. When you total this part here, divide by 5 because there are 5 focus. What do we get? 62. 62 over 5. Okay, so this is 62. So the MAD for um, mean absolute deviation at point A at 0.01 is simply what? 62
5.
over 5, which is what?
12.4.
12.4. All right. Are we clear on that one? 12.4. And we do the same for the second one here. So 102 minus what?
85.
85. I'm sure these are the things you submitted. Okay. So we have 17, 21.60. Okay, so 17, 21.6 and 0. 17, 21.6. 90 minus 90 is 0. Then this minus that, what do we get? 12.8 and 0.2.
105.
And 0.2. Okay. Then in total up here, what do we get? 51.6.
Mhm.
Okay, so what is the MAD at 0.2? 51.6 over what?
Should be 4.
There are five throughout. One, two, three,
Oh, there are
four,
5.
five,
One,
including
two,
the zeros.
five.
What do we get? Some of you completely lost, or you're just in the office, you can't talk because I don't want anyone to be behind. 10.32.
10.32.
Okay.
Uh, for the first one, why didn't we include the 85 minus 85, the zero,
Zero.
the first one?
Because these are the
Yes.
ones, the starting point. If you want, you can. You still get the same average. You get zero, then it's okay. But usually for the first one,
But
this
is
is
it?
what is helping us to predict this. 85, 85, 85.
Oh, okay. All right. Okay.
Mm.
I understand.
All right. Then finally, the MAD for um the MAD at 0 point what? 0.3. Okay.
I have a question.
Uh-huh.
If for example your math figures are just maybe a point off, like that means the answer is wrong.
Mm-hmm. Yeah. But no
Okay.
one will get it wrong, please. For this one, it's coming exact as it is. So memorize with terrible exactness in case the calculator is misleading you, eh? Okay.
Okay, thanks.
Yeah. But avoid errors. I don't want to make you comfortable. All right. So what do? We find the summation of these ones here. So the differences here um would be 17, 19.9, and 2.5. Okay. 17, 19.9, 2.5. And what? 10.7, 2.5. 2.5. Okay. Then you total up. What are we getting? 10.52. When you total up, what are we getting? This total here, we're going to get 52.6. What do you do to the 52.6? We divide by what? 5. And what we get?
10.52.
10.52. So what can you say about which one do you pick here? So you pick the smallest one. So we have what? 12.5, 10.32, and 10.52. So which one is more accurate? The focus for under 0.2.
10.3.
Okay. Focus under 0.2 is more accurate. Okay.
I'm sorry, I have a question
Mm-hmm.
on row row 10 and 12.
Mm-hmm.
You take those as absolute numbers. You don't take the negative.
You get the negative. Yeah.
So because when you get 90 minus
Oh yes, 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 yes.
92.5,
You get the you get the positive number. That's what's called mean absolute deviations. So if you get a negative, that's what it means, mean absolute. Whether it's a negative one, very good observation. You get them as positives. Very
okay.
important observation. All right. So quick recap on the differences. So after getting the actual focus under year one, year two, you get the differences for each of them. So the actual trend divided by the forecasted trend. So week 8, 9, 10, 11 up to 12. So 102 minus 85, we get what? 17. 110 minus 86.7, we get 23. In absolute, it's positive. This one minus, we get that, we get a positive. This one minus that, we get this a positive. This one minus that, we get this as a positive. Similarly, in week 2, we start 102 minus 85, 17. This and that, we get that. This and that, we get that. 95 minus 94, we get that. So we total up. To find the mean absolute deviation, we divide this one by 5. So the mean absolute deviation for week 1 is 12.4. Same here, we total up here and we divide by 5. We get our 10.32. All right. Then we go to our other week under 0.3. We do the same, we sum up and we get our mean absolute deviation here. Then we go to our summary table to now compare which one has the least alpha. So which one has the least error? So this one has 12.4, this one 10.32, 5.2. So this is the most accurate, slightly accurate. So we pick this. So 0.2 is the best because it produces the lowest mean absolute deviation. All right. So this is how it is done. Okay. I don't know whether you are liking this topic. You're able to reduce on the probability jargon. Are we together?
Yes.
Okay. So when it comes, not if it comes, when it comes, you do what? Just memorize that the most accurate is 0.2. All right. And the answer was what? Was this. So usually when lecturers are coming for the first time, they also want to make an impression that the result we are producing are good. So the failure rate should not be high. All right. Thank you so much for your time. I need to go to another class. Unless there are any questions, speak now or for one. Yes.
Thank you. Are you going to share this recording?